Okay, so let us solve problem number 1. Two objects whose charges are 1 coulomb and -1 coulomb are separated by 1 kilometers. 1 kilometer. Compared to the 1 kilometer distance, the sizes of the objects are so small. Find the magnitude of the force that either charge exerts on the other. So for this problem, we have problem number 1. Okay, so supposing we have, this is particle 1 here, Q1, and then we have Q2. So Q1 is 1 coulomb, Q2 is -1 coulomb. So Q1 exerts a force on Q2 Q1 exerts a force on Q2. Q2 exerts a force on Q1. So this is the force exerted by 2 on 1, and this is the force exerted by 1 on 2. And they are equal in magnitude but opposite in direction. So the distance between them is 1 kilometer. Distance between their centers, or that is 1,000 meters. So F is equal to K Q1 Q2 over R squared. So that's 8.9875 times 10 to the power of 9 Newton meter squared per coulomb squared times the absolute value, di ba? So we don't include the charge. So 1 coulomb times 1 coulomb divided by 1,000 meters quantity squared. So the force exerted by Q2 and Q1 and Q1 and Q2 are equal. This is the F here. And pila na siya? 8.9875 exponent 9. Okay, let's just divide directly by 1,000 squared. 17975 over 2. Over 2. And diba, we can cancel coulombs here. We can cancel meter squared here. So that's newtons, which is equal to 8987. So unsa ni siya? This is the force exerted by 2 on 1, and which is equal to the force exerted by 1 on 2. And this is an attractive force. Let's proceed to problem number 2. So for problem number 2, we have 3 charges, and we are to find the net force acting on Q1. Okay, so for this one, si Q na-exert of force ni Q2 na-exert of force ni Q1, si Q3 na-exert of force ni Q1. So, this is 2, this is 1, this is 3. So we are just looking for the net force that is acting on Q1. So Q2, because negative man si Q2 and positive si Q1, so there is force of attraction nila. So force, so this is the force exerted by 2 on 1. And this is the force exerted by 3 on 1. Okay, so both are directed towards Q1. So F12 is equal to 8.9875 times 10 to the power of 9 Newton meter squared per coulomb squared. Q1 is 3 microcoulombs, which that is 10 times 10 to the negative 6 coulombs. And Q2 is negative 4. So absolute value, that's 4 times 10 to the negative 6 coulombs, divided by the distance between them, which is 0.2 meters. So multiply this by 3 exponent negative 6 times 4 exponent negative 6. So that's 2157 over 800. Newtons. Okay. And then F13, force directed by charge 3 on 1, is 8.9875 times 10 to the power of 9 Newton meter squared per coulomb squared times 3 times 10 to the negative 6 coulombs times 7 times 10 to the negative 6 coulombs divided by the distance between them is 0.15 meters squared. And that is equal to 5033 over 600. So the net force acting on Q1, F net on 1, is equal to, so force 1, 2, or the force exerted by 2 on 1 is directed towards the right. So that's positive. And because F13 is directed towards the left, so minus. So 2157 over 800 Newton minus 5033 over 600 Newtons. So the force, net force on 1 is equal to, or let me just baliktad the notation. F1 net. F1 net. So minus 2157 over 800. Okay, so it's negative 5.6921. So the net force acting on charge 1 is directed towards the left. This is F1 net. Problem number 3. 3-point charges are the vertices of a right triangle such that Q1 is negative 86 microcoulombs, Q2 is positive 50 microcoulombs, situated at 52 centimeters west of Q1, and Q3 is positive 65 microcoulombs, situated 30 centimeters north of Q2. Find the net electrostatic force exerted on Q3 due to Q1 and Q2. Problem number 3. So we have 3-point charges, which are at the vertices of a right triangle. So supposing this is Q1 here. Q1, which is negative 86 microcoulombs. Tapos si Q2 is nasa west. So meaning here. Q2 is positive 50 microcoulombs, and Q3 is situated 30 cm north of Q2. So meaning directly north, it's here. Q3, it is positive 65 microcoulombs. And we are looking for the net electrostatic force exerted on Q3 due to Q1 and Q2. So the distance between Q1 and Q2 is 52 centimeters. And between Q3 and Q2, that's 30 centimeters. Which means that the distance between Q3 and Q1, okay, is equal to the square root of 30 squared plus 52 squared. Square root of 30 squared plus 52 squared. That's 2 square root of 901. And this is centimeters. Diba? Because this is a right triangle. This is directly north and this is directly west. So nipurma na siya right angle yan, 90 degrees. And also we can solve for this angle here. This angle theta here, which is can be solved by the function tangent. So tangent theta is equal to 30 centimeters over 52 cm. So theta is equal to the arc tangent of 30 over 52. So 30 over 52, our angle is 29.98163937. Let's store that in A. So let's just write 29.98 degrees. So that is our angle. So now we are looking for the charges exerted on Q3. So if this is our Q3, Q2 is positive, Q3 is positive, so there is repulsion here. So meaning the force exerted by Q2 and Q3, this is Q3 di, is away. So it is directed adong dito. This is the force exerted on 3 by 2. And then there is negative C Q1, positive si Q3. So meaning directed padulong sa iyaha, no? Ang gi-attract ni Q1 si Q3. So this is F on 3 by 1. But naa na siya horizontal and vertical components. So this is the force F31X, and this is F31Y. And remember that this angle is 29.98 degrees. So again, what are we looking for here? The net electrostatic force exerted on Q3 due to Q1. So we are to find first the forces acting. So F32 is 8.9875 times 10 to the power of 9 Newton meter squared per coulomb squared times Q2 is 50 times 10 to the negative 6 coulombs, and Q3 is 65 times 10 to the negative 6 coulombs. Divided by the distance between them is 30 centimeters or 0.3 meters quantity squared. So the force exerted by 2 on 3 is 8.9875 exponent 9 times 50 exponent negative 6 times 65 exponent negative 6 divided by 0.3 squared. And that is equal to 46735 over 144. 46735 over 144 newtons. And then the force exerted by 1 on 3 is equal to 8.9875 times 10 to the power of 9 Newton meter squared per coulomb squared times Q3 is 65 times 10 to the negative 6 coulombs, and Q1 is 86. 86 times 10 to the negative 6 coulombs, and the distance between them is 2 square root of 901 cm. So we'll just convert that to meters. So 1 meter is 100 cm. And then we'll raise that to the power of 2. So let's just input everything in our calculator. We just change this 50 to 86. And in the denominator, we are going to put 2 square root of 901 over 100. And then raise that to the power of 2. So 139.401 newtons. Okay, let's just store that in B. Okay, so how do we find now the net force acting on Q3? So we are going to find the summation of the horizontal and the vertical forces. So F3x is equal to basically equal to F31x, right? Because there are no other horizontal forces. So which is, what is F31x? F31x is F31 cosine of the angle theta. Or that's 139.4010 Newton cosine of 29.98 degrees. So F3x is equal to, that was our answer earlier, that was B, and then cosine of angle A. So 120.7471 newtons. Let's store that in C. Wala na. Again. Okay. All right. And then F3y. So the vertical component of the net force acting. So we have F32, which is directed upward. So this one, and the downward, no? So minus, okay, minus F31 sine of theta. So F32 is 46735 over 144 newtons minus 139.4010 Newton sine of 29.98 degrees. So calculator, that's 46735 over 144 minus recall A, recall B, sine recall A. Okay, that's 254.8868. 254.8868 newtons. That is F3Y. So it's positive, so it's directed upward. So meaning the net force F3 is equal to the square root of F3x squared plus F3y squared. So that is the square root of 120.7471 Newton squared plus 254.8868 Newton squared. So F3 is equal to, okay, let's just store this in D. Square root of recall C squared plus recall D squared. So 282.0410. That is the magnitude. And for the direction, let's use P. That's arctan of F3y over F3x. So that is arctan of 254.8868 Newton divided by 120.7471 newtons. So our angle, arctan of D over C, 64.65 degrees. So positive Cx o positive Cy, meaning atong resultant nga vector is here. This is F on 3. Yan mo ni siya ang 64.65 degrees. This is the resultant.